So now we are going to move our attention to comparing pointers to array. And there's like they are 90% same, and there are few differences that you should be aware of. So an array for all practical purposes is a pointer as well. That's the summary. And let me go ahead and now explain through an example what's happening or what the differences are. So what you see here are two strings. And strings in C are nothing but characters lined up in the memory back to back, delimited by a null pointer. Meaning when we have a string like so, this will be put in memory as P, I, Y, U, S, H, and a null pointer. Or not null pointer, but a null character. Null pointer is something we'll take a look at later. But these are like characters, and this is a null character. So this is like a string as represented in C. And what you see here, the next one is also a string. And I could have also just as well chosen to represent the array initialization like so. Right? Both are equivalent. Both are absolutely equivalent. And here I need to specify the null character or null terminator, so to speak, explicitly. Whereas if I use double quotes and type within that, then it's just taken care of. It's automatically, the compiler kind of adds that in for me. So now let me go ahead and draw 7 more boxes here. These boxes, by the way, are representing our friendly you know memory cells going top to bottom, increasing order of address. And so each one of these is like one character or one byte. So it's taking like each address is a byte away from the previous one. Same here. Let's say this starts at hex 30, hex 31, hex 32, blah blah blah. And what goes here is lowercase p, lowercase I, lowercase y, lowercase u, lowercase s, lowercase h, and the null character. Okay, so this is the setup. And now what we are doing here is we are saying that, hey, this line here means I need a character pointer, which is called, again, somewhere in the memory, there is name ptr, right, which is a character pointer. So it is going to point to a location where a character exists, or a character would exist. And what we are saying is, hey, compiler, go ahead and put Piyush somewhere in the memory, all caps, and then take name ptr and put the address of P, the first character, the 0th character, so to speak, when indexing, and store the address of it. Right? So name ptr then is essentially storing the address where all caps Piyush would start. P, that is where it is pointing to, right? And then similarly, when we say name underscore array, open close brackets here, we're saying, hey, name array is a character array, and the elements of that array are lowercase p, I, y, u, s, h, and null pointer, or null character, sorry, null character. And could you then go ahead and just put that array in the memory. Now the thing is, name array, name array just by itself, uh, not the open and closing square brackets, just the name array would be a pointer pointing to lowercase p. That is how it is, right? And there is a difference between the both still. Both of them behind the scene are pointers, pointers to the content, but there are certain differences, and those differences is what you need to remember. For all practical purposes, an array and a pointer are same, right? The way you think about them is same, with just additional thing that array differs from a pointer in few aspects, and those you need to remember, which we will discover. Okay, so this is our setup then. In the memory, you're supposed to imagine line number 4 and line number 5 line number 4 and 5 mean something like so. The addresses here, that changes. I chose some, representative addresses, but real machines have different addresses, and those you cannot speculate upfront. All right, so let me clear this. Let's go back to the example. Let me go ahead and uncomment these lines, line 8 and 11. And what I need to do now is compile and run the code. So I'll go to the burger sign here, then go to terminal, and then create new terminal. And let me pull this up here. I'll go ahead and do gcc main.c. Everything compiled fine, no problem. Then /a.out. And all right, so let's see what's happening here. So if you see a name ptr, when I print it like a string, when I say, hey, I'm going to give you this pointer, take this pointer and see, print that as if there was a string stored there. So it will go ahead and print Piyush. And notice it is able to stop after H because there is a null character. So every time there is a null character, the string is assumed to be complete or finished at that point. So that is why we see Piyush here. When I say, hey, print name ptr as a pointer, show me what address it has, then the address is this. Right? And then the next thing we do is put a star here and then say, hey, star name ptr, can you get me the content that is being pointed to? That is being pointed to by the name ptr, so it prints the uppercase P, right, which is here. And notice now we are doing the same thing with an array, and we say, okay, go ahead and print the array as a string, prints Piyush, no problem, all lowercase, which is right here. Then we say, okay, give print name array as an address. Okay, goes ahead and prints that as an address. %p is for printing the address. And then we say, okay, print a character, and that character is interpret name array, wherever it is pointing to. Again, behind the scene, an array is a pointer. That's my claim. So can we dereference it? Yes, we can. So when we try to dereference it, it only prints the first character. So both of these are acting as if they are pointers. The character pointer is a pointer, but an array is also acting as if it's a pointer. Now let's go ahead and then explore the differences, right? If behind the scene an array is a pointer, how does it differ? Why call an array an array? An array obviously signifies that there are similar elements or elements of the same data type, a bunch of them clubbed together back to back. Like in this case, we had characters, back to back, right? We had P, we had I, we had Y, and so on. So that's what the notion of array conveys. But can an array be imagined like a pointer? Absolutely, yes. Yes. And it's again, there are differences, and those differences is what you should know, just so that in certain cases you can reason about, will the array comply with the pointer behavior or not? All right, so let's take a look at what the differences are. Let me go ahead and comment this line here, a bunch of lines here. So what do we have? What's going on? Okay, so we are now going to see the space taken by the pointer name ptr, which is this, and the array, which is this, right? The variables itself. So name ptr, how much space in memory does that take? And name array, how much space does this take? And what I'm going to do is use the sizeof a macro, or a function that's provided by the C standard library, which is available here, and then print the numbers, how much size it takes. And then what we do here is we have another example of integer array and integer pointer, and what I'm doing is again having an array. I'm not specifying the size of it, so the compiler figures out that there are 3 integers being stored. So x is an array, X is an array, so X must be pointing to the starting value of integer 10, 11, and 12, so it's pointing to 10. And each integer then, recall, is 4 bytes long. And this is important, right? Okay, so we're printing the sizes again, right? And I'm doing something special here, which is I'm defining xptr, which is a pointer to an int, and I'm saying, hey, could you point to X, the array? So there's also xptr, which is pointing to this memory location, right? The stat of the array. This is a mouthful, too much information. So maybe go back, rewatch this thing till here, because what follows is the exact difference that I always want you to remember. So let me get rid of all of this. Let's go ahead, compile, run, and something happen. Let me bring back my, doodle, and right. The important thing to note here is this, which was our print here. So size of name ptr and size of name array. So size of name ptr is 8 and size of name array is 7, right? And question is, why the difference? And that becomes clear as we look at the second example. So here we had three integers, each one of them 4 bytes long, and three of them will take up 12 bytes, right? So when we say size of an array, we get 12 bytes. But when we say size of a pointer, we get 8 bytes. And why is that so? So turns out that a pointer on this machine takes up 64 bits or 8 bytes, right? And that can also be confirmed by looking at this number here. This was an address, right? So 1 byte, 2 byte, 3 byte, 4 byte, 5 byte, 6 byte, and the 7th 8 byte happened to be 0, so that's all right. But it's kind of taking up 8 bytes on this machine. So a pointer has a size of 8 bytes. But when we say, hey, give me the size of an array, it will give us the entire length of the array. How much bytes are all the elements of the array taking up combined? So the 12 here makes sense. And the 7 should make sense from the standpoint that Piyush itself is 6 it's 6 bytes, but then the 7th byte is the /0 or the null character. So hopefully then this difference, number one, in the sizes, that is conveyed, or I've been able to convince you with that. The differences in the size of an array and size of a pointer. Array is the size of an array will give you size of all the elements, the space occupied by all the elements combined of that array, whereas size of a pointer will only give you size on the number of bytes it takes to save the memory address. That's all. Behind the scene though, both are treated like addresses, except when you ask for size, the compiler understands that in case of an array, I must return the size of all the elements together in the memory. Whereas in case of a pointer, it's just the address being how much bytes will the address take to store. All right, so with that, let's move on. So the next thing we want to do is explore another difference, and this I would say is the fundamental difference between pointer and array. And that is, if you look at the example here, and let me actually keep this uncommented. So what is going on? So this should sound familiar from the previous run. And what is happening here is I now have A, which is also an array of 10, 11, and 12. Could have been different. So I have two arrays, uh, 10, 12, 11, and 12, 10, 11, and 12. This is A, this is X. Both of them are stored in different parts of the memory. Even though the array elements are same, doesn't mean that they'll be saved at the same location. That is number one. Just be mindful of that. Now what I'm trying to do here is I'm saying, hey, let me take A, which was behind the scene a pointer, right? And let me try and assign X to it. So whatever X was pointing to, let me go ahead and make, A equal to X. I'm reassigning A, so to speak. And for the sake of example, let me actually, just to avoid any confusion, let me just make this 110, 111, 112, just so you know. So what we are then trying to do is then, we had X, which was 10, 11, 12. Now we have A, which was 110, 111, and 112. This is like, let's grab this out. So what I'm trying to do is, this is how the situation was. I'm trying to change this to this. So I'm trying to do something of this nature. And my claim is that is not allowed. That is not allowed. You cannot take the array variable. You can take the array elements and reassign them. That's a different story. I could try and modify this entry, this entry, this entry. Different story. What I cannot do is take the array variable and assign it to another array, what do you say, variable. Or I cannot assign it to a new address, and we'll see that now. So that is what this example is showing. So this should fail, right? Let me then hide this. Let me go ahead, compile, and yeah, it's an error, and we see, hey, reassignment. What is it saying? So it's saying error assignment to expression with array type. So I'm taking an array type, which is A, and then trying to reassign or assign it with the value of X, right? So, and formally, this is a pointer type and this is an array type. Just if you want to distinguish between both of them, behind the scene, both are pointing to the memory. It's just that there are differences in terms of size and in terms of assignment. So an array type cannot be, reassigned, so to speak. So let me then go ahead and also try this. So can I then maybe have an int also? So let's say, can I have an int here, which is I equals 1024, let's say. So I have I here, and then can I assign A the address of I, and then also xptr, let's that is okay. And then can I take xpt I ptr, and then assign it the address of I, right? So in this case, then this obviously should be all right, because it's like an integer pointer pointing to an int. Here I'm having a pointer that's trying to point to A. We'll look at that. And then we were now trying to take an or rather, we were trying to take an array type and then give it the address of I. I also happens to be 4 byte long integer, which is 1024. So is this allowed then? And my claim is that's also not allowed. Let's see. So we come down here, attempt a recompilation, and that just fails, right? And okay, so there is a redefinition of xptr. So let me just get rid of this. Yeah. So let's try and compile again. And it says, hey, assignment to expression with an array type. So this is also not allowed. So you cannot take an array and variable and assign it an address of some another memory location. Hopefully that is, now I have hammered home the point, hopefully. Let's now go ahead and comment this line here, just so that a few things become clear. Let's try and recompile the code, and it works now. It compiles fine. So the point to note is xptr was a pointer. We are reassigning it, but xptr was recall 8 bytes long because it's a address, and we had A, which was which was pointing to what, 10, 11, 12, all integers. So each one of this is 4 bytes. Right? So we were not able to assign a the value of x. That did not happen in the previous run. But what we can do is take a pointer and then make it point to an array. That is allowed. Right? So that is what we are seeing here. Not here, but here. We have a pointer on this side, and to that I can assign the array element, the address of the array element, right? Or array data type. So hopefully a few things are clear to you in terms of what is allowed, what is not allowed.